Let's jump right into this explainer. In 1926, the sheer brutality of nature collided head-on with human innovation. It's the story of how a devastating natural disaster actually became a historic turning point for life-saving technology, ultimately changing how we prepare for the worst forever.
So that brings us to a really crucial question. How did an encounter with a massive, catastrophic storm end up proving the true potential of early radio warning systems? To really understand this, we've got to transport ourselves back to the booming industries of the 1920s. Think about it. Back then, coastal communities were deeply, dangerously vulnerable to the unpredictable wrath of tropical weather.
Let's trace the timeline of this threat. It started as a broad area of low pressure, just steadily gathering strength in the central Caribbean Sea around August 20th. By the 21st, we're looking at tropical storm strength. And by the 23rd, full-blown hurricane status just north of the Yucatan. But then, on August 24th, reacting to a nearby cold front, the storm made this sudden, highly dangerous curve northwards. Suddenly, the U.S. Gulf Coast was squarely in the crosshairs.
Now, right as this monster storm was approaching, the Weather Bureau was actually experimenting with a revolutionary new piece of tech. On that very day, August 24th, the Evening Independent newspaper announced that weather maps were going to be sent to ships at sea by radio. And we aren't just talking about a voice broadcast here. They were testing the wireless transmission of actual visual surface weather analysis maps. It was a massive leap forward in maritime safety, happening at the exact moment a major disaster was brewing.
Meanwhile, behind the scenes, the Bureau was in full panic mode, frantically issuing warnings via mail and telegraph all the way from New Orleans to Medjugorje and eventually over to Mobile. As the storm aggressively curved toward Louisiana, forecasters realized the threat was escalating by the hour, so they bumped it up to a full hurricane warning. But here's the catch. Local officials still had to rely heavily on the traditional methods of the time, like physical telegraphs and even local Boy Scout troops, to run and distribute these alerts as fast as humanly possible.
Then came August 25th. The climax of the disaster arrived as the hurricane made landfall near Houma, Louisiana. We're talking terrifying winds approaching 115 miles per hour. Modern meteorologists, looking back at the data we have today, would classify this as a Category 3 major hurricane. But to the folks on the ground in 1926, categories didn't mean a thing. It was just a monster. A literal wall of wind carrying an astonishing amount of kinetic energy that immediately started tearing coastal communities apart.
The intensity of this system was just staggering. It was marked by a massive drop in central barometric pressure, all the way down to 955 millibars. Now, in meteorology, pressure is basically the engine of a storm, right? A drop this steep creates incredibly violent, destructive winds. Observers at the time noted a mind-boggling pressure difference of over 20 millibars in a span of less than 30 miles between Houma and Morgan City. It was a tightly wound, highly concentrated engine of destruction. And that sheer physical force manifested in a massive 15-foot storm surge that absolutely battered Turbone Parish. To put that into perspective, a surge of that magnitude doesn't just flood a coastline, it batters it, submerges it, and completely rearranges the landscape. It heavily damaged the New Canal Light and wreaked absolute havoc on the lighthouse at Timbalier Bay. Small fishing schooners that didn't make it back to port in time were, tragically, simply lost to the rising, violent sea. But here's where the story shifts. As traditional infrastructure totally collapsed and entire cities plunged into darkness, the invisible resilience of radiophone broadcasts stood in stark contrast to severed telegraph wires. In places like Morgan City, those vicious winds literally snapped the physical communication lines in half, completely severing their connection to the outside world. Think about that. If you relied on a physical wire, you were instantly cut off and isolated in the dark. But radio signals, those invisible waves, transmitted seamlessly, completely uninterrupted through the howling winds, reaching the exact people who desperately needed to hear them.
The physical toll on the ground, though, was absolute devastation. It grounded trains, sparked fires, and completely ruined the region's agricultural livelihood. This wasn't just wind damage. It was the crippling of an entire regional economy. We're talking an estimated 90% of Houma's sugarcane crop completely wiped out. Southern Pacific passenger trains were forced to just halt on the tracks in Avondale because the winds were too deadly to keep moving. The state capital, Baton Rouge, completely lost power. A mail plane literally fell from the sky, a chemistry building at Tulane University caught fire, and Donaldsonville was swamped with an unbelievable 14.5 inches of rain in a single 24-hour period.
Yet amidst all this darkness, a hero emerged. While homes were losing their roofs and roads were completely blocked by debris, Government meteorologists were taking careful notes on how their experimental communication methods held up under the ultimate stress test.
The official government report plainly stated that radiophone broadcasting and reception made possible a better distribution of warnings than in previous storms. And that's it. That is the historic turning point. Radio emerged from this total disaster as a proven life-saving warning system when the old world completely failed, when sturdy physical telegraph poles literally snapped like twigs under 115-mile-per-hour winds. This brand-new, invisible technology held strong.
Ultimately, the storm claimed 25 lives and caused $6 million in total damages. But that death toll could have been significantly higher without the reach of those early radio warnings. To put that $6 million into perspective for 1926, that was a massive economic blow to the region, with $4 million of that being direct infrastructural damage. 25 lives lost is a tragedy for sure, but when you really consider the sheer violence of a hurricane making a direct hit on a populated coastline, those early radio alerts absolutely undeniably prevented a much larger catastrophe.
So, we have to ask ourselves, did the terrifying collapse of infrastructure in 1926 directly pave the way for the instant invisible warning networks we all rely on today? The evidence points to a resounding yes. That storm was the moment radio transitioned from a neat novelty to an absolute necessity. But as we look around at our own modern, hyper-connected world, it leaves us with one final, unsettling question. If our current digital grids were to face a storm of unprecedented scale tomorrow, what exactly is our invisible backup plan today?